Welcome to Zaption Tour 8-1, adding and subtracting polynomials. All right, there are a lot of words in this session, so I'm going to make sure that we pause the video and write down the definitions of these words as we go along. There are 7 boxes, so let's jump right into this. And here is the first box, okay? The question I'm asking you is, what is a monomial? Now, this is an Algebra 1 course, so we want to make sure that we get our words down correctly. So here is the definition that we're going to be using. A monomial is a real number, a variable, or a product of a real number and one or more variables. So I'll say it again. It's a real number, a variable, or a product of a real number and one or more variables. Here are some examples of monomials. The number 18 is an example of a monomial because it is simply just a real number. So that fits the definition. Okay? Z is an example of a monomial because Z is what we call a variable and it fits the definition. Okay? Negative 5x squared is also a monomial because it is the product of a real number and a variable. So each of these are examples of monomials. Here's one more example, right? 2.5xyz. This is a monomial because the 2.5 is a real number, x is a variable, y is a variable, z is a variable, and we are multiplying all those together. That's what we mean by a product of real numbers and more than one variables. So hopefully we now know what a monomial is. Box number 2 is all about the degree of a monomial. The question is, what is the degree of a monomial? Now I have to tell you that the degree is nothing more than the sum of the exponents of the variables. Okay, so in case we do not know what the word degree means, this is what we're talking about. It is the sum of the exponents of the variables only. So take a look. Here's number 1. I have 5x to the first power. Okay, so the degree of this entire monomial is a degree of 1. So the degree is a 1. This is a monomial in example 2. It says 6x squared y to the third. X is a variable, y is a variable. I want the sum of the exponents of the variables. So the degree of this monomial is a degree of 2 plus 3, so a degree of 5. The number 4 does not have a variable attached to it. So if I wanted to, I could say this is like x to the 0, because anything to the 0 power is worth 1, and I have not changed the value of my original number 4. So therefore, any number that sits by itself has a degree of 0. It's a good thing to know. Take special note of that because I'm going to ask you this one in just a second. Take a look at number 4. It says 8xy. 8 is the number, the real number. X is a variable. Y is a variable. Together they make up a monomial because I am multiplying a real number by 2 different variables. The degree of this monomial is the sum of the degree of the variables. Therefore, the degree of this monomial is 2, because 1 plus 1 makes 2. The degree of this monomial, hopefully you see, is a 5, because I take 4 and I add it to 1. Don't forget that any variable that does not have an exponent written is implied to be an exponent of 1. Okay, number 6, you're on your own. What would the degree be of the number 11? Box number 3 is asking the question, what is a polynomial? Well, you may realize that the word poly means many monomials. So if I have many nomials here, so this is saying that a polynomial is nothing more than a bunch of monomials put together, and that's exactly what the definition is. So when we use the word polynomial, we are referring to either a single monomial or the sum of other monomials. So here are some examples of a polynomials, okay? Let's do 3x squared plus 6x. Notice that 3x squared is a monomial, And 6x is a monomial, and we are adding them together, so collectively, this makes a polynomial. Okay? Here's another example of a polynomial, right? What if I did this? How about negative 11x to the fifth plus 9x to the third minus 8x to the second plus 14, okay? Each of these individual terms make up monomials, right? Negative 11x to the fifth is a monomial. 9x to the third is a monomial. Negative x squared is a monomial. 14 is a monomial. When I start adding or subtracting them together, collectively they make up a polynomial. Okay, so I really hope we understand the difference here. So even though that it says sum in here, and like some people say, well, there's a minus sign right there, well, we could just say that this is the same thing as adding a negative 8x squared. So we are allowed to do that. So it is okay to have minus signs in there as well. So that's what a polynomial means. Okay, box number 4 is now asking, what is the degree of a polynomial? Well, we learned earlier the degree of a monomial is the sum of all of the exponents combined together. Well, when we talk about a polynomial, we first have to make sure that we're only referring to one specific variable. So if we have a polynomial that has multiple variables in it, then the degree is unspoken of in this class. But all of the polynomials that we're going to be taking a look at are going to be in one variable. What I mean by that is they're only going to have one particular variable. Like as an example, all of these have x's in them. That's what I mean by in one variable. So therefore, the degree of a polynomial in one variable is the degree of the greatest monomial exponent. So here's what we mean by that. When I put it into an example, it makes a lot of sense. Here is a monomial, 3x to the fourth. Here is a monomial, 7x to the fifth. Here is a monomial, here is a monomial, and here is a monomial. Collectively, they make up a polynomial. This is not new. We learned this in the last box, okay? What is new is the degree of this polynomial. This is a degree of 4, this is a degree of 5, this is a degree of 3, this is a degree of 7, and this is a degree of 1. So what we do is we look at the highest degree's exponent. Obviously it's a 7, so therefore the degree of this polynomial is 7. So this is a 7th degree polynomial. Here's another example. 5x squared plus 6x to the third minus 12x to the fourth plus 9x. What would the degree of this polynomial be? It would be a 4. It is a 4th degree polynomial. I only have one variable, which is x's, in all of my terms. So therefore, I look at the highest degree monomial, and this is a 4th degree. Now, it is standard practice to write every polynomial in what's known as standard form. Standard form. So what does that mean? That means we take the highest degree monomial and write them in descending order. So the standard form of this polynomial right up here would be negative 12x to the fourth plus 6x to the third plus 5x squared plus 9x. So notice that all of my exponents are in descending order. That's what it means to be written in standard form. Okay, box number 5 is a big box, and we're going to learn how to classify polynomials. So I'm going to give you a minute to copy down this chart. Okay, now that you have the chart copied down, I'm going to show you how to classify a polynomial. We can do it in two ways. We can either classify a polynomial by its degree, which is highlighted in yellow for you, or we can classify a polynomial by its terms, which has been highlighted in green for you. So let's take the first example. The number 6. It's a polynomial. Okay, the degree of this is going to be a 0. Why do you ask? Because I could write this as 6 times x to the 0 power and not change the value of my 6. So therefore, the degree is 0, okay, and the name using this particular degree would be constant. Okay, now take a look at the number of terms. Well, there is only one term in this thing, so therefore we call this a monomial. So we have a constant monomial. So the way that we would describe it is a constant monomial. Okay, take a look at example number 2. All right, the degree of this is a 1 because the x power has a value of 1. So if it is a degree of 1, the name that we use would be linear. So by its degree, we use linear because it is a degree of 1, which makes sense because after all, this is nothing more than a line that has a slope of 5 and a y-intercept of 13. So it makes sense that we would use linear. Now, how many terms does it have? Well, it has a 5x and it has a 13. So it has 2 individual monomials. So there are 2 terms, and so we would call this a binomial. I know this is a lot of information, but it's going to be second nature in no time. Take a look at this third example. Okay, the degree, of course, is a 2. Okay, so the degree is 2. Okay, so therefore, we would call this a quadratic. Okay, it's a parabola. It makes a parabola. So we call that a quadratic. Now, tell me the number of terms. Well, it has 1, 2, 3 individual monomials. So there are 3 different terms, and we call this a trinomial. Okay. Let's go back to this one. Okay, the degree of this is a 3. The next one, so 7x cubed, that's a 3. Okay, the degree that we would give to this one would be cubic. Okay, cubic means 3. So if the degree is to the third, think of 7x to the third, that's cubic. The number of terms it has is still just 1 though, so we would refer back to this as a monomial. Okay, so this is a cubic monomial. And then take a look at the last one here, right? We have a degree of 4, so the degree is 4. So anything above a third degree, we just call this the number and then the degree. So this would be a 4th degree. We don't really have any names for it. So if it was like a 5th or 6th or 7th degree, you would just write out the word for that number. Okay? The number of terms that this thing has is 3, because it has the 8x to the 4th, the negative 2x to the 3rd, and the 7x. So anything with a number of 3 terms would be a trinomial. Okay, so this would be a 4th degree trinomial. Okay, finally, getting to the heart of the lesson. How do you add polynomials together? Well, this part's really easy once we understand the rest of the words. So take an example, 4x minus 5 plus 12x minus 3. I am adding a binomial with another binomial. That's what that means. So you know what you do? You add like terms. So 4x and 12x, these are like terms because they have the same variable and they have the same exponent, which is 1. So 4x and 12x make a grand total of 16x's. Negative 5 and a negative 3 added together make a grand total of negative 8. So this would be the answer. So this is the easy part of the lesson compared to all the other words that we had to get through. Okay, let's do this pretty quickly. X squared and 3x squared give me 4x squareds. Okay? 2x and a negative 5x collectively make a negative 3x. And 4 and a 1 make a positive 5. So we have added this correctly. Okay, let's do the third example here. I have 9x to the 5th and an 8x to the 5th. Therefore, collectively, I have 17x to the 5ths. Notice that I'm writing these in standard form. I have a positive 6x to the 4th and a negative 2x to the 4th. So collectively, that makes a positive 4x to the 4th. Now, notice I only have 1x squared. I have 2x squared over here, and I have 3x squared over there. Now this is negative 2x squared, is that correct? Yeah. And a positive 3x squared collectively make a positive 1x squared. Notice I don't have an x cubed. That's okay. I don't need to write it in. It's fine. And then lastly, I've got 5 and a negative 6. Well, that makes a collective negative 1. And we have added the polynomials together. Okay, last box, box number 7. Subtracting polynomials, all you have to be careful of is to distribute your minus sign to every single term that's after that minus sign. So as an example, here's what we're going to have. We're going to have x to the 3rd minus 3x squared plus 5x minus 7x to the 3rd minus 5x squared plus 12. Okay, so here we go. X to the third minus 7x to the third gives me negative 6x to the thirds. And I like to cross them out so that I know that I'm done with them. Negative 3x squared and a negative 5x squared make a grand total of negative 8x squareds. I like to cross them out so that I know that I'm done. 5x's and no other x's is just going to be a positive 5x, huh? Nothing I can do to that one. Then lastly, a positive 12, and I have written my difference in standard form. Okay, part B, you try this one all on your own. Tell me what you get.